Alrighty then, corn children. Children of the corn, it is the highly anticipated Arithmetic Sequences Part 2 video. If you have not watched Part 1, just stop right here and go back and watch Part 1. Alright, Arithmetic Sequences are sequences where we are adding the same number every time. Yeah, adding 3 every time. And we saw in our last video that we can come up with a formula to find any term in the sequence using this. So let's say I want to know what number is 87 terms out. I'm not going to add 3 87 times. No. I'm going to come up with a formula and then plug 87 in. So let's go ahead and find our formula. Alrighty, explicit formula. The n is the variable, so a sub n stays a sub n. We fill in the first term of the sequence. Where would you find that? I would find that in the front. It's the first number. Yeah. N stays an n. D is the common difference. It's the number that we added every single time. So that's our formula. Now, if you want to, and who wouldn't, we could distribute the 3, combine like terms, and make it a little bit prettier. Yeah, I'm all about the pretty. So I would use this as my formula. It's just easier to work with. All right, so double check with me. We know that the second term is 11. If you plug a 2 into this, do you get 11? Yeah, I know, right? Right. All right, so let's go ahead and find a term. Let's say we wanted to find the 40th term. We wanted to go 40 places over. Yes, you could add 3 all of those times and get over to the 40th number. I don't want to do that. I want to be able to find the 40th number just by plugging in 40. This is all we do. We use the formula. If a sub n is 3n plus 5, then the 40th term, also known as a sub 40, is just 3 times 40 plus 5. That's 125. Look, I found the 40th number without having to go 40 places over. Hey, if it works with 40, it'll work with 400. Yeah, it will. Hey, let's do another example just to see if we can really get this, yeah? Awesome. Alrighty there. Here's my next example. And some of you might be saying to yourself, that's not an arithmetic sequence. We're not adding the same number every time. We're subtracting 10. Well, yes and no. You can think of this as adding a negative 10. The arithmetic sequence is built on the condition that you are adding, but you're allowed to add negative numbers. I know, right? So in this particular case, our D value is a negative number. So the formula in general, a sub n would be 100, n is the variable, it's a formula, and D is negative 10. I know, right? And of course, you can distribute the negative 10. Distribute. And combine, and we get 110 minus 10n. If you want to check it, fill in a number. If you fill 3 into this, you better get 80, because that's the first, second, third number in the sequence, yeah? All right. Now, can we find, for example, the 80th term? Well, yeah, I'm sure you could subtract 10, subtract 80 times over. I'm not going to do that. The 80th term, also known as a sub 80, would be 110 minus 10 times 80. We math that out and we get the number. Wow, that is fun. I mean, what could be more fun than that? I know. We could take all of these numbers in a sequence and we could, instead of just putting commas between them, we could add them. Yes, yes, and yes. All right, here we go. Now, here's what we're doing, people. We have an arithmetic sequence. Whoa. We have an arithmetic sequence, and now we want to add up the numbers. Adding up the numbers in an arithmetic sequence is also known as an arithmetic series. An arithmetic series, a partial sum. Now, I am not going to take the time in this particular video to show you where the formula comes from. Perhaps that will be a future video. Ooh, something to look forward to. All right, so let's go through this. If I said I wanted to add up the first 20 numbers, this would be S sub 20. N tells you the number of numbers. Yes, I said that. The number of numbers. So if you're adding up 20 numbers, N is 20. If you're adding up the first 300 numbers, N is 300. A sub 1, that's the first number in the sequence. A sub N will be the last number that you add up. Why? Well, if you're adding up 100 numbers, N is 100, and this is the 100th number. It would be the last one that you would add up. I know that's a little tricky. Let's go through an example. It'll be fine. Come along. All right, here's our problem. It says here to find the sum of the first 70 terms of this sequence. Okay, 70 terms. We can do this. We can do this. So here's my idea. If we're finding the sum of the first 70 terms, we're finding S sub 70. How many numbers would we be adding up? What would be the number of our numbers? Well, it would be 70. A sub 1 is the first number in our sequence. It's a 6. And A sub 70 would be the last number that I'd add up. It'd be the 70th number. Well, there's a small problem. The 70th number isn't listed here. And I don't want to really have to go 70 places over to find it. I need to know what the 70th number is. If only we had a formula to find it. Yes, that's right. We have to do work within the work. We are going to use the explicit formula to find the 70th number. Whoops, A sub 70. Here we go. The first number in the sequence is still 6. Now, we are going to go ahead and fill 70 in. It's our 70th number. What's D? D is that common difference. What is the number we're adding every time? We added 0.5. We added 0.5. We added 0.5. D is 0.5. So we math this out, and I've already done it, and hopefully I've done it correctly, and we get 40.5. So apparently, if we go 70 places over in this sequence, we would end up at 40.5, and that would be the last number that we would add up. So all I have to do is fill that in right here. So we have 70 over 2, 6 plus 40.5. Go ahead, use your calculator, and I got 1,627.5. I know, right? That's kind of fun. I know, I told you it would be. Hey, I wonder if we could do another example. Well, okay, let's. Now this example is still an arithmetic sum, but it's a little different. This time I told you when to stop. This time I told you the last number. We have the first number, we have the last number, we have a pattern here. But because of the ... I did not tell you how many numbers there are. We don't know how many there are. Now you could, if you hated yourself, write them all out and then count them up. I'm so not gonna do that. So this time, it is the n that we don't know. So I'm gonna leave that temporarily in n. Our first number is 100. The last number in the sequence is 15. So how do we go about finding n? Well, here's what we're going to do, people. We're going to, again, use the explicit formula, but this time we're going to find n. Well, how do we do that? The last number is 15. 15 is our a sub n. It's the nth number. We want to know how many places over would be 15. A sub 1 is 100. We're finding the n, and d is the number we added every time. We're not adding 5, we're adding -5. All right, so you have to solve this out. You can distribute if you want, or you could subtract the 100, divide, and then add 1. I'm assuming you can do that, and we get that n is 18. Apparently, first number, second number, third number, fourth number, that is the 18th number. We are adding 18 numbers up. So we fill the 18 in here. We math that out, and the answer is 1,035. Booyah!